Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about Introduction to DOS and BIOS interrupts. Before going to the DOS and BIOS interrupts, first we need to know what is meant by interrupt. So here, interrupt means the process of interrupting the normal execution of a program to carry out specific task is called as an interrupt. So interrupt is an external event that makes the microprocessor to divert its execution. Now, here generally the interrupts may be due to many ways. So here some of the ways are represented. The interrupts may be due to some peripheral devices. So interrupts due to the peripheral devices means here the peripheral devices may be any external devices. The peripheral devices may be any IO devices. Here generally if any peripherals are generating interrupts, they are called hardware interrupts. So here the interrupts that are generated because of these peripheral devices, they will be through two pins. One is INTR pin, another one is NMI pin. So INTR represents interrupt request and NMI represents non-maskable interrupt. So if any external devices are generating interrupts through any of these two pins, they are called the interrupts generated by peripheral devices. So here, if any interrupt is coming through INTR signal, in order to accept that interrupt by 8086 microprocessor, compulsory the interrupt flag bit should be set. In another case, if any interrupt is coming through NMI pin, that is non-maskable interrupt pin, that particular interrupt will be accepted only even though the interrupt flag bit is not set. That means the interrupt that is coming through NMI signal, it is independent of the interrupt flag. Whether it is set or not, if any interrupt is coming through NMI pin, compulsory that particular interrupt will be accepted. So such type of interrupts may be generated because of this peripheral devices. And another way to generate these interrupts means, another way is because of some special instructions in the program. So for example, if we are using special instructions which will be in the form INTN, that N value represents, this N value represents type number. So here the type number will be varying from 0 to 255. Why? Because in the 8086 microprocessor, totally in the interrupt vector table, there are 256 interrupts available. So if we are using any such interrupts, those are the interrupts that are generated because of the special instructions in the program. Now, and processor may also be interrupted due to exemptional conditions. That means during execution of any program, for example, if you take a division operation, if you wanted to perform the division operation, compulsory we have to provide the value of divisor and dividend. So in such cases, if the value of divisor is too small compared to the dividend, and if the dividend value is very large, or we can also say the value of dividend is 0, in such case, it is going to produce a result, that is quotient and remainder, where its value is not able to fit in proper registers. So automatically here interrupt will be generated. So such type of interrupts are called exemptional condition interrupts. That means the interrupts that are generated due to exemptional conditions. And next, coming to the classification of interrupts, Here the interrupts are classified into different types. First one is hardware and software interrupts. Hardware interrupts are also called external interrupts because they are the interrupts generated by external devices. That means if any interrupt is coming through the pins of 8086, interrupt pins of 8086 microprocessor, those interrupts are called hardware interrupts. Generally, as we know, in 8086 microprocessor, only two interrupt signals are there. One is INTR, that is interrupt request. Another pin is NMI, non-maskable interrupt. So only two interrupt requests can be allowed from any of these pins. They are called hardware interrupts. And here software interrupts means the interrupts that are generated due to the instructions what we have used in the program. That is why the software interrupts are also called internal interrupts. And the next classification is vectored and non-vector interrupts. So here, which interrupts are called vectored interrupts means, if the interrupt type is vectored interrupt, here no need to provide any address. The control will be automatically branching to that particular address because that particular interrupts will be having fixed value, fixed address. But whereas here compared to the, coming to the non-vectored interrupts, to this non-vectored interrupts, compulsory in order to execute these interrupts, address should be specified in the program because the interrupts that comes under this classification will not have fixed addresses. That is why to make the control to branch, compulsory here the address should be provided. Next classification is maskable and non-maskable interrupts. Maskable interrupts means the interrupts that can be disabled. That means whatever the interrupts that are coming through INTR pin of 8086 microprocessor, those interrupts are called maskable interrupts. The interrupts that can be disabled. That means the interrupts that can be ignored. Non-maskable interrupts means the interrupts that cannot be disabled, the interrupts that cannot be ignored. So for example, if any peripheral devices are generating interrupt through NMI pin, those interrupts are called non-maskable interrupts. Compulsory, if any interrupt is coming through NMI pin, they have to be executed. They cannot be ignored. So this is the classification of interrupts. Next. So coming to the DOS and BIOS interrupts. So DOS represents DOS, disk operating systems. And here this BIOS represents basic input output system. So here this DOS represents disk operating system. And next type of interrupts, BIOS interrupts, and this BIOS represents basic input output system. So here this DOS interrupts and BIOS interrupts, they will be accessing this application program and input output devices. So these interrupts will be used to program this application program and input output devices. So they will be acting as a medium in order to interface this application program and IO devices. Next. So coming to the DOS and BIOS interrupts in detail. Here, generally in IBM PC, the part of the operating system is located in the permanent memory. So here permanent memory is ROM, that is read-only memory, and the part will be loaded during power up. So here the part loaded in ROM is referred to as ROM BIOS, and the other part which is loaded in the RAM during power up from hard disk is known as DOS, that is disk operating system. Next. So what is the purpose of this DOS and BIOS interrupts means? Here this DOS and BIOS interrupts are very useful in order to provide the special functions. Here generally if you take a computer, generally it is going to take input from the keyboard, mouse, or it is going to use the output devices like display, that is monitor, like that. So let us see in this DOS and BIOS interrupts how to make this keyboard, mouse and monitors with the help of this DOS and BIOS interrupts. So here this DOS and BIOS interrupts are used to perform some very useful special functions such as displaying a data to the monitor and reading data from the keyboard, not only keyboard, mouse. Okay. So in order to do such operation, what are different DOS and BIOS interrupts that should be used? And so they are used by identifying the interrupt option type, which is a value stored in the register AH. So in order to perform particular operation, the value what you are storing in AH register is very important. Generally we know different registers that are available in 8086 microprocessor. Generally if you take AX register, that AX register is called accumulator. So in that AX register, it is a 16-bit register. It is divided into AL, that is lower order 8-bit, and AH, which is called higher order 8-bit. So generally in order to perform any operation in this DOS and BIOS interrupts, the value what we are storing, what we are loading into AH or AL or BL or BH, that means the value what we are storing in the registers is very important. So let us consider here the first type of interrupts, that is DOS interrupts. So DOS represents here disk operating system interrupts. So some of the DOS interrupts we will learn here. So for example, if we consider here INT10, it is one of the DOS interrupt. And the operation that is produced by the DOS interrupt is video screen. Now we will see what are all the values we have to load into the register such that how they are going to operate. Now, so here the option is chosen by putting a specific value in AH register. That is why either if it is DOS or BIOS interrupts, the value what we are loading into this AH register is very important. So according to that, the operation will be performed. So generally, since we are considering this INT10H interrupt, it represents video screen interrupt. So generally the video screen, screen means it consists of some set of rows and columns. So consider we are taking one screen which consists of 80 columns and 25 rows. So if this is the case, generally, now, so here if this screen is divided into 80 columns and 25 rows, this row and column number will be associated with each location on the screen. And the top left corner is the starting corner of the screen, which represents the corner value 0, 0 and 0, 0. So one value is related to row, another value is related to the column. And that is the screen. And if you come to here, if you consider this is a screen, this is called the left corner. This is called the left corner, that is top left corner. And its value will be indicated with 0, 0, 0, 0, representing the row and column. And this area is called bottom right corner. And this bottom right corner, automatically it will have the value 24 and 79. So what is this value 24 means? This value represents row and this 79 value represents column. Now, so here the center of the screen, what will be the value of the center of the screen now? Here if this is the screen what we are considering, center of the screen means this is the center of the screen. So the center of the screen value will be 0C27 in the value of hexadecimal. So this specific values have to be fit in proper registers. Then this INT10H interrupt will be called. And this INT10H interrupt will be performing different functions. So for example, here if we consider function 06, this is provided by INT10H. If this function is 0H, the function that is performed is here clearing the screen. So clearing the screen means what are all the specific values you have to load into the registers. So in order to perform this clear the screen operation, we have to load function 06. So what is this function value represents means, this function value represents the value what we have to load into AH register. So AH should be loaded with 06. So loading AH with 06 means we have to write move AH, 06. Then AH value will be loaded with 06. So if it is 06, where this 06 represents the function number. And the value of AL is 00, which represents the page number. And the value of BH is 07, normal attribute. And if the value of CH is 00, we have just drawn the screen and represent what will be the top left corner value and what will be the bottom right corner value. So that value should also be loaded into the registers. Here CH value will be 00, which represents the low value, starting value. And CL will be 00, which represents the column value, starting value. And here DH is 24, row value representing the ending. And DL is 79, column value representing the ending point. So just we have drawn the screen representing, this is top left corner of the screen having the values 00 and 00 and representing this as right corner having the values 24 and 79. So if this is the thing what we have to perform, we have to load that particular values into all these registers. And here AH and AL, it is AX register, and BH, it is base register. This CH and CL, they are related to CX register, counter register. The value of this DH and DL, they are related to extended accumulator register. So in order to perform this function, proper value should be loaded into proper registers. And same INT10H also provides another function, that is function 02. So this 02 represents the function number and its operation is setting the cursor to a specific location. Like, so here whatever the number we are observing here, the function number, that number should be loaded into AH register. So what is the value we are loading into AH register is very important in this DOS interrupts. So if AH is 02, what is this 02 means? It represents function number. And the value of DH represents the row number. That means the cursor will be present there. And the value of DL, what we are giving, it represents the column number, position. And another function is also provided by the same INT10H interrupt. And that function is here 03, where this 03 represents the function number. And if we are loading this 03 value into AH register, it is going to get the current cursor position. That means we can know where the cursor position is. So for this AH should be loaded with 03 because this is the function number. Next, so the value what we are loading into BH register will be saying the current viewed page number, and the position that is returned in DH and DL registers will be saying the row value and column value. Now, another function is produced by INT10H instruction is function 0E. So this 0E should be loaded into AH register to perform the operation like output a character to the screen, so that whatever the character you have entered on the screen, that particular character can be observed. So here AH should be loaded with this 0E value. That 0E is called a function number. And in order to perform this output a character on the screen, we should also consider this AL, and the value what we are loading into AL will represent a character that will be displayed. That means whatever the character you are placing at AL register, that particular character will be displayed. And the value of BH00, it represents the currently viewed page, and BL00, it represents the default foreground color. That is about INT10H. And another interrupt which is present in this DOS category, Disk Operating System category, is INT21H. So this INT21H, this is one of the DOS interrupt which is used to input information from the keyboard and display it on the screen. And here different functions are provided by this INT21H instruction, and here function 09. So this 09 represents the function number. So if you are loading this 09 value into AH register, it will make display a string operation. So here AH value should be loaded with 09. So this 09 is a function number. And the value what you are loading into DX register, it is a 16-bit register. So you have to load the 16-bit value. So that 16-bit value what we are loading into DX register, it represents the offset address of the ASCII data that should be displayed. That means whatever the input character we are giving, it will be converted into ASCII value. And another function provided by this INT21H is function 02. So this 02 represents displaying a single character. Only single character can be displayed. So in order to display a single character, we have to load the value 02 into AH register. So this AH register is 02, which represents the function number. And so you are going to see a single character on the screen, and that character will be DL register value. It will be the ASCII code of the character, and that ASCII value will be displayed on the screen. And another function provided by INT21H is function 01. So if you are loading this 01 value into AH register, it makes input a single character. That means a single character can be given as input. So AH will be 01, which represents the function number. And the value of AL should be the ASCII code of the input, and it is echoed to the monitor. That means it should be displayed on the monitor. And another function provided by INT21H is function 0A. So you have to load this 0A value into AH register to input a string. So this 01 is to input a single character, but to give input as a string, we have to load this 0A into AH register. So AH register is 0A, which represents the function number, and the value DX will be the offset address at which the string of data will be stored. And another function provided by INT21H instruction is function 4C. That means if you are loading this 4C into AH register, it terminates the program. See, AH value is loaded with 4C, which is a function number. 4C is a function number. And another DOS interrupt is INT16. So this INT16 interrupt is going to do the keyboard programming. So keyboard means which key will be pressed, how to identify that key. Okay. Now, so for this INT16 is going to perform different function. Among that, this function 01. So if you are using the function value 01, it is going to check a key press without waiting for the user. That means which key is pressed will be checked. So for that, since this is 01 representing the function number, this 01 should be loaded into AH register. So upon executing, the ZF will be 0 if there is a key pressed. ZF means 0 flag. And another function provided by this INT16 interrupt, that is DOS interrupt, is function 00. So this function 00 represents the value of AH register. So if the value of 00 is loaded into AH register, it is going to perform the operation keyboard read. So this 00, which represents the function number, it will be loaded into AH register so that the keyboard read operation will be performed. And AL will be loaded with the ASCII character of the pressed key. And that is what about the DOS interrupts, disk operating system. So totally in the DOS interrupts, in order to perform that interrupt, what is the value we are loading into AH register is important. Now, coming to the BIOS interrupts. So BIOS interrupts are called basic input-output system interrupts. And one of the BIOS interrupt is INT10H. So this INT10H represents the operation video service interrupt. Okay. So that means video service interrupt means this will directly control the video display in the system. Now, so here in INT10H, the value of AH register should be selected properly in order to have the video service provided by this interrupt. So in this case also, properly use the value of AH register. And another interrupt provided by this BIOS interrupt is INT11H. So this INT11H is used to identify, that is determine, the type of the equipment installed in the system. So when this interrupt is executed, we can identify the type of equipment installed in the system. Like we have to, in order to use this particular interrupt, we have to load the AX register with a value FFFFH, and then only the INT11 interrupt will be executed. So in this BIOS interrupts also, the values what we are loading into the registers are important. And next BIOS interrupt is INT12H. So this INT12H represents the memory size. What is the memory size of a system? That can be identified when this INT12H instruction interrupt is executed. Now, so after executing this INT12H instruction, the value of AX register contains the 1 kilobyte blocks of memory installed in the computer. That means the AX register will be loaded with this value. And next BIOS interrupt is INT13H. So this when this INT13H instruction is executed, it is going to control the diskette. That it is nothing but floppy disks. So all the disks can be controlled by this INT13H interrupt. So that will be within the size 5.25 or 3.5 inches in size, and also hard disk drivers attached to the system. So all these things will be controlled when this INT13H instruction is executed. And the next BIOS interrupt is INT14H. So when this INT14H instruction is executed, so it is going to control the serial communication ports attached to the computer. So in order to control the serial communication ports, INT14H interrupt instruction should be executed. So generally, there are two communication ports, COM1 and COM2 in a computer system. But in newer machines, there are also additional communication ports along with 1 and 2. We can also have 3 and 4. Now, so another BIOS interrupt is INT 15H. So when this INT 15H instruction is executed, this instruction will control the various IO devices that are interfaced with a computer. So this same instruction, it allows to access the protected mode of operation and extended memory systems on 80286 and Pentium processors, which are nothing but advanced processors. Next BIOS instruction is INT 16H. So when this instruction is executed, it is going to control the keyboard in the system. Now, so generally this interrupt can also be accessed by DOS interrupt also. That is whatever the operation that is produced by the DOS interrupt INT 21H, the same operation is here, that is INT 16H also. Both the interrupts operation is same. And next BIOS interrupt is INT 17H. So when this interrupt is executed, it is going to access the parallel printer port, which can also be called as LPT1 in the system. So in order to access the ports, that interrupt will be used. So this is what about the DOS and BIOS interrupts. So in this DOS and BIOS interrupts, the value what we are loading into registers is very important, because based on that only particular operation will be performed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.